Broadcasting from Washington, D.C., this is Insider's Guide to Energy.
Welcome to the Insider's Guide to Energy. I'm your host, Chris Sass, and today with me is Eloisa De Castro. Eloisa, welcome to the program.
Hi, Chris. Nice to be here.
I am excited to be here. Batteries and storage are one of the topics I enjoy talking about, and you guys are doing something innovative. So why don't we start with what problem are you looking to solve?
Well, we're looking to solve stationary energy storage. And what's really important there is to make stationary energy storage a lot more affordable. What we've really seen deployed so far in stationary energy storage from the electricity system perspective is really that most of the installations have been for short durations. We're looking to get more longer duration energy storage on the market and supporting the adoption of renewable energy.
All right. So one of the things I do on this podcast is I kind of ask some of the more basic questions. So it seems simple: long duration, short duration. That seems like a definition we would all understand. What is your definition of a longer duration storage solution?
That's an excellent question because a lot of people have different definitions for long duration energy storage. So, what Enerpoly is working on is we're working on a what I would consider medium duration energy storage, which is actually around 4 to 10 hours of energy storage. Short duration, I would say less than 4 hours. And very long duration for me is greater than the 10. But what we are seeing, because the market isn't so developed in even the medium duration energy storage, is that we're already considering that long duration energy storage that we really need to get in order to get more renewables.
And then what are some of the challenges of that medium duration or that longer duration storage that aren't taking place today? Why don't we have that yet?
Well, what's really interesting is that we do have batteries that last for longer durations. The issue is that these batteries that we currently have in the market today are still too expensive to be able to deploy in what we would consider longer duration energy storage. So, in the stationary energy storage market, what we really need to see are the battery costs going down so that we can deploy a larger battery. Like, let's say if you have a certain power requirement, then if you have a longer duration of that power requirement, say 4 times as much, then you need 4 times the size of battery. And as it is today, many of those possible solutions are still too expensive to deploy and feasibly have in the economic sense. So, if you are able to get the affordableness of the batteries or the cost of the batteries to go down, then you'll be able to more affordably deploy what is a longer duration energy storage.
Okay, so what I've heard you say so far is economics are part of the reason we don't see this at scale, not technology. Is that true,
That's
or the
right.
technology driving the economics?
That's right. The economics are a huge part of the issue. And we need to have batteries that are economic for these longer duration energy storage, as well as having good performance in that long duration energy storage.
And what kind of size are we talking for this stationary? Are we talking behind the meter? Are we talking grid scale? What are we looking at for your problem statement that you're trying to solve?
We're looking at primarily what will be growing right now in the near future is going to be behind the meter in commercial and industrial. The solution that we are aiming to offer is a modular energy storage. So this is something that can be designed for something smaller like renewable in your residential. So anywhere from several kilowatt hours to all the way up to smaller grid scale. And we have seen modular batteries deployed in, greater than 100, maybe up to thousands of megawatt hours before.
And then what kind of technology are you leaning on to do this? I mean, we see a lot of lithium ion, we see flow batteries out there. What are you all focused on?
So Enerpoly focuses on zinc-ion batteries. What we do is we innovate on batteries made on the anode side with zinc, on the cathode side with manganese dioxide. And these are historically very affordable materials so that we can reach these very affordable batteries for the stationary energy storage.
And is this a technology that's proven and been around and you're just refining, or are you developing new technology here?
We've had batteries made with zinc and manganese dioxide before. So, zinc and manganese dioxide are actually the materials that go into zinc alkaline non rechargeable batteries. These are the same ones that you have in AA batteries that can power remote controls, toys, small devices. And they have really been able to, in the past, several decades ago, revolutionize that industry. And this is an existing supply chain that we're building off of, but making this innovation in that our batteries are a lot more rechargeable and, in that sense, applicable to stationary energy storage.
Okay, so more rechargeable, is that in terms of number of times that you can charge the
Yes,
battery and discharge the battery? And what
yes.
about performance? Is that, if I want to get, if we have the conversation between power and energy, and I want to get all of that power out of or get everything out of my battery, how does that impact stationary as opposed to, let's say, an EV battery?
Well, EV batteries really, the EV batteries really depend on being small and light, and they do need to be high power. What we achieve with zinc and manganese dioxide batteries is an energy product. So we're not aiming for a power product. And power products are things that can go into the shorter duration energy storage. For longer duration, it's fine for the power to be released over time and hence longer duration, right? For Enerpoly's zinc and manganese dioxide batteries, the ideal or recommendation is discharge durations of 2 to 10 hours. And really, we're hitting that sweet spot when you get to about 4 hours, which is great because this is the area where stationary energy storage really needs to expand a bit more.
And then I guess so I get the discharge time, but typically are you not having a sudden demand? So if I'm a manufacturing firm and I have your stationary batteries, um, I'm not anticipating using them until I need to use them, right? Or is this a scheduled kind of event ahead of time? This is not kind of like the spot market for energy gets hard for me and I use my battery type of thing? I guess I'm a little confused by your answer.
Well, if you look at the way that stationary energy storage is really expected to be used when you have it co-located with renewable energy, is that you're spending a portion of your day charging the battery, and that may be something like 8 to 10 hours. And you need to discharge your battery usually during let's say if you have solar, then you would be charging the battery during the day, and then you would use the battery during the night when you're not generating any energy from your solar. You could also use the battery for energy shifting during the day. So if you have high peak prices during the hours of, just around noon and a little bit afterwards, that's typically when peak prices are. Then what you can do is discharge your batteries at that time instead of paying the higher prices for energy, and then charge your batteries in the evening when the prices are low. And so these are just a few examples of use cases where you're not waiting for the battery for a long time and you are actually planning on using the battery during the day at a certain time and recharging it at a different time.
Makes sense. Now you're the CEO of Enerpoly. I'm sorry. Um, what exactly is the mission? So you're building modular batteries. Is it actually production or is it technology that you're focused on?
We're doing both. So we're innovating on the battery technology and we're building battery cells and battery packs. So what we've innovated on is not only the electrochemistry that goes inside the battery, but also the manufacturing process. We've tailored the existing lithium ion battery manufacturing process, which is well established. We know that it's very scalable. And we've tailored it to our battery chemistry so that we can use very similar machines, use very similar skills. That's what's already existing in the battery industry. And make a process that, with a few improvements, because of the safety and the I would say the simplicity of the technology, in the fact that it's very, there are fewer steps to build it, then we can really make a very scalable manufacturing process and produce many batteries and address the need for the stationary energy storage to support the electricity energy transition.
You're also headquartered in Sweden, if I'm not mistaken. So you're somewhere that's pretty advanced in the energy transition compared to other countries. Perhaps where I'm sitting here in the US, I would may argue that Sweden may be ahead in some areas. Um, is your market starting out in the Swedish market? Is this where your home base is or your first footprint?
It's definitely our first footprint when it comes to manufacturing, but this is a technology that's needed worldwide. It's definitely something that's very valuable in Europe. The way that we've been seeing the markets develop is that there's really an increased need to find solutions that, where you can have a local solution and have a local supply chain of batteries. That's something that's important in Europe. It's something that's important also in the US. And when we have a technology made with zinc and manganese dioxide, because the materials are so abundant throughout the world, then there is that option of having that local supply.
Got it. So I think we're talking supply chain issues or supply chain improvements, and I've seen that quite a bit in the battery space. We've had a number of guests coming in talking about that. That seems to be one of the areas where there's a room for improvement. Um, now, is this? Are you seeing this in the life cycle of a battery? Then dramatically reducing maybe carbon footprint or the impact on the environment by doing this way?
I do think so. With being able to have a local supply, that does lower the carbon footprint when it comes to distribution. Interestingly, zinc and manganese dioxide already, if you compare with the footprint of the materials to lithium iron phosphate batteries, LFP, then we're getting a significant reduction in the carbon footprint already. On top of that, in the manufacturing process, there are also significant reductions in energy consumption. And, this comes from the safety of the battery. For example, for those that are familiar with lithium ion battery manufacturing, then they would know that dry rooms are a very significant portion of the energy consumption for lithium ion battery manufacturing. And Enerpoly's technology is very safe and does not require a dry room environment. And therefore, we can reduce the energy consumption there. We can also reduce the energy consumption because we don't use NMP. We have fewer steps in the total process. And in our last process, we have about 90% uh, faster formation process. So we are able to also reduce the time for preparing the battery for delivery.
And then I guess why hasn't this taken place before? Why does it take a bunch of innovators and founders to bring this to technology? Because batteries aren't particularly new. We've had them for quite some time. So why disruption now?
That's true. Um, I think that people have been working on relevant battery technologies to really improve the supply chain for quite some time. Um, so it's really the combination of the innovation that we have. So using the materials and then making them far more rechargeable is the first part, but then also when there's a need for it. So in 2020, right after COVID, it was really the time when the technology had reached the laboratory, had been proven at laboratory scale and was ready to be commercialized and turned into a commercial product. And because of the timing, with the emphasis on the supply chain coming from coming from the difficulties that we had during COVID, and now also more recently, after what's gone on in Russia and Ukraine, Europe is really pushing to have better better control over its energy. This is something that's become increasingly important.
So you talked about the supply chain. You're saying it's maybe energy security issue. So a zinc ion battery, does that mean I can source things more locally, or I guess help me understand how that alleviates the fear of energy security.
Well, there are more than 60 different countries that produce zinc. So, so this is an issue that the battery industry has really been seeing, really been more concerned about in the last decade or so, or maybe even more. And being able to use materials that are not only abundant but available worldwide and already have this high TRL level of the supply chain is incredibly attractive for being able to build the technology that you need now and being able to scale it up in time to address the needs of the energy system.
So speaking of scaling up, I saw a news release that you guys had just won a grant. Maybe you can share a little bit about the grant you just won. What is that, and how does that help you scale?
Yeah, we recently secured a grant from the Swedish Energy Agency. It was, and I'll say it in both US dollars and Swedish kroner. So it's 88.5 million Swedish kroner, and that's 8.4 million US dollars. And this is a really significant grant for us because it jumpstarts the building of our first fully functional plant for manufacturing zinc-ion batteries. We're going to be building a mega factory, 100 megawatt hours per year capacity for zinc-ion batteries, and it's going to be in Stockholm, Sweden.
And now, when you have something like this, is this a little bit like power purchase agreements or things like that? Have you pre-sold battery or capacity then to folks when you build the plant? Is that part of how you finance these kind of plants?
The way that we finance the plant is, I mean, it's a combination of grants and investment. So we will also be seeking our Series A, in addition to this grant and other state funding that we have received.
Awesome, awesome. Where are you at this stage of a company? How big is your organization today? How many engineers do you have working for you?
Well, we have 17 people, and I believe that 15 of them have engineering degrees, although not all of us work within engineering anymore.
Oh, that's
Yeah.
awesome. And with your 17 people, you build this plant. Are you looking to then continue to build other plants or license your technology out to others as you get growing?
The aim is to really do what's necessary to commercialize the technology. What what our approach is because we have developed this technology, the electrochemistry, that's always going to be our core competency, right? But we've also developed manufacturing processes and IP around the production of the technology. And this is something that is very important to being able to commercialize the technology because it's it's essential for having a technology that works, and the process innovations that we have are essential to having a technology that scales.
Now,
This is something that we can commercialize by continuing to build more plants, but we're also open to having partnerships with other organizations in this entire journey.
that was going to be my next question, is kind of the ecosystem, because you said that your storage is different. And so do you need to partner? Is it good to partner within the ecosystem? For example, if there's wind or if there's other solar, does the way you storage make a different way you store, or the amount of capacity change the way either of those other elements perform? And do they need to marry up somehow? Is there any kind of need for the companies to work together to optimize based on what you can now do?
Yes, I think that there's a need to optimize at the various stages of development. So, I mean, what we do is we develop the battery cell. We're now developing battery packs, and there are areas that you can optimize for certain applications, right? And these are all partnerships that we value within the industry, and the requirements of an application may vary slightly. At the end of the day, it does continue to rely on the affordability of the batteries, so the cost of the batteries, and and so this is something that we can innovate on in the component level, in the battery cell level, the likely the most. But I have seen that in other parts of the energy industry, even when there is a an innovation in a small component, the way that it's been deployed and the decisions that you make, the design decisions that you make, and the way that it's been deployed has affected the overall affordability of the product. So yes, the short answer is yes. It does matter for us to have these types of partnerships and to be able to understand how we can continue to deliver even more value past where we specialize in the value chain, and we can do that through partnerships.
Awesome. And then it sounds like the electrochemistry is your company's intellectual property or specialty. Do you go down to managing the cells, or do you just use software off the shelf to do the kind of management of your batteries?
We do the management of the cells, the algorithms that are closest to the battery cell. Yes.
Awesome. Well, cool. So there's a lot of transformation coming. I guess, how do you see this dramatically changing things? So, turn the clock ahead 5 years, your plants are up and running. What's going to be different? What am I going to notice different about your solution, and what impact have you made?
I think that we're going to see a lot more energy storage deployments in buildings, definitely. And as we're seeing an emphasis on being able to deploy battery systems that are easy to work with for fire departments or for permitting reasons, then we're going to see a lot more deployments of zinc-ion batteries, particularly our chemistry, which is very safe in the kinds of applications that really require this and value that part, in addition to the affordability of the batteries.
What about density and weight? Is there a significant difference between the weight of these battery packs, these modular systems?
Yes, there is. So right now, the batteries that we have are about 1.5 times larger in size than a lithium iron phosphate battery, the LFP. And in stationary applications, the energy density is not something that's incredibly important. Most of the people that are deploying energy storage for stationary are really looking at other factors, depending on the application. Um, Affordability is really the most important one.
Yeah.
I think I sound like a recording of myself, but it really is always the first question that we get when we speak to um, people that are deploying stationary energy storage, and and size and weight don't matter. In particular, weight is really less important than volumetric as well.
All right. So footprint is what people are looking at, but they're basically looking at your solution as an economic alternative to make the project pencil out, and the rest of the stuff is secondary. Is what I'm hearing you say.
Yes, I'd say so.
Which does make sense, right? We saw that with solar when solar panels finally became more cost effective. They became universally accepted everywhere, right? And so I think storage is, well, comparatively to what the early days. I think battery storage is the same, right? When we see price come down, I think we'll see more connection of buildings that are putting solar in. What percentage in Sweden right now are also adding storage as a component? Is that pretty much universal yet, or is it still putting just solar in and thinking about the battery storage?
I don't have the exact numbers for 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 how many are also installing batteries when they've installed solar, but we have seen that the numbers for Europe, that it is very advantageous. So when solar installation, I'm sorry. So when we see that there's a solar installation and it isn't paired with batteries, then typically the amount of the energy that's generated that becomes used by the owner is something like 30 to 40%. But when you pair the solar with batteries, then you're able to significantly increase your self-consumption of the energy that you're generating. So it goes to between 70 and 80% usually. And so that's a double of the self-consumption of the amount of energy that you're producing. So it is very attractive.
And then what technologies are you competing with in the future? So we know what's on the truck. We know you're more cost effective today. What keeps you awake at night as a CEO going, okay, who else is going to encroach on the same space? Because it's got to be a race to get the least expensive across the board. If that's one of the gates, I'd imagine others are trying to solve the same problem.
Yeah. Well, I think that the big challenge is being able to scale up really quickly. So the way that I see it is, um, in stationary energy storage, what what we really see as a challenge in scaling up, or what we really see as a challenge for emerging battery technologies, is being able to scale up and compete in price with LFP from China. I mean, it's a it, yeah, LFP from China and technology from, oh, I don't want to say that. Maybe remove that.
We can remove this last question.
Yep.
It's okay. So, all right. Um, I guess one of the things that comes to mind with me being here in the US is we're trying to onshore production, right? With the IRA, there's an effort to do that. I assume Europe has got some initiatives to that as well. So your battery plants that you're building, will these be geographically located on different continents, different areas to try to take advantage of some of that inclination to build batteries locally? I can change the whole line of questioning. It doesn't look like you want to go there. It's fine. I'm sorry.
No, I mean it's fine. I just don't. I also don't want to um, uh, give give details that I'm not sure of,
That's fine. That's
and then end up doing something else.
All right. So how would you want me to frame imagine we're playing volleyball and you're giving me the set and you're going to get the spike. How would you want me to frame that set for you?
Well, I mean I would just want to say that I do think that local production is going to be a very important part of sustainability. It's going to be a very important part of energy security, and it's going to be an important part of achieving the net zero goals that we have globally. It doesn't matter which geography you're from. So I do expect that local production is going to be a very essential part of our business model. We are manufacturing these batteries in Sweden. I mean, we have Swedish IP in the battery cell electrochemistry, as well as the battery cell manufacturing process. And this is something that I know is very valuable in Europe. And I am American myself. I understand that it is also important for the US to have local production, both for both for economic and sustainability reasons. So what we would like to do is find the best way to commercialize the technology, and local production is definitely going to be a big part of it.
Awesome. I'm going to use that answer. I probably need to backfill the question though, because I like the answer. I'm not making you repeat it because I enjoyed that, but I didn't ask appropriate questions. So I probably need to do that for our producer here. I can do it at the end here. Um, I guess one other question that comes to mind for me is I've noticed a number of people that come from the aerospace industry in energy. Why is that?
Why is that? That's a very good question. I can tell you a little bit about how I think my aerospace background helps within energy, right? So, I mean, in aerospace, anytime that you solve a problem, you need to take a full systems approach to it, right? You need to make sure that the electrical design that you're working on is something that works very well with the mechanical design. You have to take several things. You have to power satellites. I've previously worked on satellites that were powered by solar panels with batteries as backup. So I mean, it is a similar system. And so you take all of these different fields and you put them together, you make a very reliable system, and that's required for making something work in the space industry. And this kind of reliability is also something that's incredibly important in the energy industry, right? I mean, can you imagine if you know we still today had a lot of blackouts every day? That's just something that over time you want to continuously increase reliability. So making sure that all of these different components work well together is a big part of that. I think that anybody who's interested also in working in aerospace is interested in working in innovative technology, and especially today in the energy industry, we're looking to really deploy innovative technology, the kinds of sustainable technology that I think when we were studying engineering really wanted to be able to deploy, and then thought, oh, too bad it can't be deployed because it's not affordable enough. But now we're making these changes, and we're making all of it possible. And that's what we need. We need good people working on this problem.
Oh, what an awesome conversation, and what passion's coming through. I can see why you do what you do. It was great to see that passionate answer about the engineering. It does seem like you're working to engineer the costs out of the or reduce the costs and engineer the costs down,
Mhm.
which tends to happen in my experience when technology matures. So that's an awesome thing to see. Um, I guess one last question I would have is, what milestones do you hope to see over the near term that show this change taking place?
Just before I answer that question, is what do you mean a change taking place? You mean
Sorry, I'll reframe the question. So,
the sustainability?
no, what I meant is you're the
Or,
CEO of a company disrupting. You're bringing a lower cost solution. You're bringing a Zinc-Ion technology. So you say a safer, different technology. What are the next milestones that you want to see to show that you're on your path to success?
Well, we'll know that we're on our path to success when we can build a production system that is really competitive with what is industry standard today. So, being able to reach high speeds, high yields, and being a fully optimized system that can really compete um, in efficiency and in cost with the best of the best in the industry. In order to achieve this, we've already started to build our team of very high performing people, and we aim to continue to do so. And I really believe in this team, and I think that they're going to do a great job.
Well, awesome. I thank you for taking your time to share your story with us today. Thank you so much for being our guest.
Thank you so much for having me. It's
For
really nice to be here.
It has been a pleasure. For our audience, I hope you've enjoyed this conversation and getting insight into some new and emerging technology and how it's going to help reduce the cost of storage for you. And we will talk to you again next time on the Insider's Guide to Energy podcast. Bye bye for now.